Welcome, everybody. Thank you for joining us here at DGSHAPE. Today, we're going to be talking about digital dentures made easy, unveiling the DGSHAPE advantage. My name is Christian Lagos. I'm a registered denturist in Ontario, Canada. For those who may not know what that is, we are a separate sector of the dental professions here in Canada, specifically just centered around removable dentures. That could be removable traditional dentures that are analog, complete, partial, um, immediate dentures. But we also do implant over dentures as well. They are fixed, removable on locators, Novolocks, as well as bars and whatnot. I've had my private practice here in Woodstock, Ontario since 2002. In our facility, we do have our own analog and digital denture lab. Prior to and during my education period in Toronto, I did work as a dental lab in a commercial laboratory setting. So that gave me a little bit of experience on more of the analog workflow, and it helped us develop some of that analog system when we opened our clinic back in 2002. But what it also did was it also gave us a feel for how we could transition into the digital world. And that we were able to do back in 2020. Roland DGSHAPE being a big part of that transition a few years afterwards. We'll touch a little bit more about that later. But yeah, this is just in a nutshell who we are. We do see patients directly in our clinic here. And like I said previously, we do do our own lab work here on site. So my hope today is to go over a few things in relation to how that digital transformation occurred and how it improved with our milling systems here. I hope to go over our experience as users here at the clinic, the accuracy and the precision and what's possible with the machine, as well as the question that's most often asked is what's the return on this investment? So just a quick claim about where we're at here when it comes to digital. The majority of our scanners, be it the 3Shape E3 scanner or the Trios 5, those are the ones that we're using to input data into our CAD design, which is 3Shape dental systems. Our nesting software for the mill is Millbox. And then, of course, we're using the DGSHAPE software vPanel and DGSHAPE Cloud to manage all our workflows through the mill. So I would say right now our clinic is probably operating at about a 90% capacity when it comes to digital workflow, and mainly in the full upper, full lower denture aspect of things. So the system that we're using there is the Vita Vigo workflow. So a lot of our bases now are being milled, and then we're adding the teeth later on down in the processing of it. We have moved into more of the partial workflow. Where we've seen an advantage of this is in Canada right now, we've got a new dental program that is being subsidized by the government. And so we're seeing an increased amount of workflow in all dental aspects here, whether it be dentist office, dental labs, or even denture clinics. So there's been a real backup, especially when it comes to sending work to a commercial lab. So this has really been a game changer for us. The fact that we could now move into milling our own bases for either acrylic, but mostly now that we're seeing a lot more Duracetal type workflows, and the fact that we can design them here in house and be able to mill it allows us to still provide that incredible accuracy. But where we're seeing big advantages is in time. Our turnaround time for delivery of prosthetics to patients has been incredible. Being able to do this in-house. So like I said, I would say 90% of what we're doing here on the digital side of things is fulls, but we're seeing a great increase in the amount of partial dentures that we're able to do here, be it the Duracetal workflow or when we're doing acrylic bases and then milling the teeth. It's just become a phenomenal efficiency for us here at our office. So one of the things that I considered even 5 years ago, but especially when we looked at this mill, was um, what do we need it to do for us? And the biggest thing was to have an open architecture ecosystem. So meaning that we can use or bring in different types of material, that we weren't being pigeonholed to a certain workflow, a certain material, or a certain system. And this mill has allowed us to do just that. So, like I had said earlier, we're now able to bring in the Duracetal Meyerson pucks to be able to do partial dentures with. We're able to now play around and basically try different materials, different workflows, and it really does open up what our lab can do here internally. The other thing was support. We wanted to make sure that if the mill was ever down or if the systems weren't working, be it the software on the design side of things or on the CAD or CAM side of things, that we were able to get that quite readily. And through Roland, through our service provider, we've seen very little downtime. And that also plays into the reliability of this machine. A little later on, we'll go over some of the errors, but we have rarely seen this machine go down. Theoretically, like in theory, it says that it produces. We've seen this in real life where we've had this mill running almost 24 hours a day at some points. And that plays into the production. It allows us to really do a lot of full dentures, full denture bases quite quickly and overnight. So, you know, the advantage of that, not having techs processing or setting up or boiling out and all the other things that I'll talk about a little later on, has just been incredible for us. The machine too, we looked at maintenance. One of the key things to downtime is, you know, are we maintaining this? Is there a lot of parts to change? Is there a lot of burrs to change? That was another consideration when we were looking at what we were going to do when we chose a mill. And with this, we've been pleasantly surprised that there is very little, if no maintenance over time. So in respect to the footprint, it does have a relatively small footprint. This sits in an office with us on just a table. The thing that I found remarkable was just the integration and the setup. Everything was, we installed everything, put the machine together, had someone come in, set it all up. We were operating within probably 24 hours. It comes with everything that you'll need to get going, from the extraction unit to the tools. It pretty much comes plug and play. The other advantage was that with the compressor, we didn't have to go with fancy compressors. I have a picture of the one that we use here. It's a 20-gallon, 5-horsepower compressor that really just runs seamlessly. We've had very little slowdowns with it, and it's not cut out on us. So the cost of having to have big, expensive units brought in is not a factor in this specific case. All right, so let's go over a little bit of the CAM software and vPanel, just to give you an idea of how simple this can be. With the CAM software, it is pretty much uploading patient files. So the first thing that we're going to see here on this screen is we're going to check to see which fixture we want. So the machine comes with two fixtures. One is your standard one and one is an open edge, and I'll go over that a little bit later. Traditionally, with a lot of the bases that we're using to mill the Vigo system, we're just using the traditional standard fixture. So we'll pick our fixture. The next thing we're going to do is look at our patient. So it's just a matter of you going to your manufacturing drive, finding the patient that you want, picking the file, which you see on the lower, just confirming that that's the file that you want. And then picking your puck. So in cases like this, where it's just the base, obviously you're going to be using a new puck, because in most cases there's not a lot of residual material left in the pucks to build another one. With the smaller, lower dentures, for example, I will keep that puck and maybe use the residual material left to do like a small flipper on the top or on the bottom. And if you notice on the side there where it's got the little numbers, uh, you'll see plus 10 on both the 25 and 30. That's where you can access like your older used puck material so that you can utilize either in the tooth material or in the base material. You can kind of draw and get into those files to be able to use the rest of the material that's available. So it's very handy because, you know, it does reduce the amount of waste in certain cases. When we're needing just a little bit of material, we're not having to go in and use new pucks. So once you've picked your puck, the next step is going to be to go in now and to nest it. So the software does a great job of just putting it in. If you want to fine tune it, you can. The beautiful thing with the sprues is that you can make them cuttable so that when it's all said and done and milled, that it allows you to remove it from the puck very easily, and it's very minimal adjusting afterwards or trimming to finish it. The final step here is just confirming your tool set. We'll go over a little bit of that in just a couple more slides, but here basically what you're telling the mill is, you know, what tools we're going to use to do this particular case. And then the computer goes through its analytics and basically figures out what it's going to send to the mill to print or to mill. So this would probably be the longest time in respect to downtime. So this can take anywhere from 25 to 30 minutes. Now, at our practice, we're not just sitting there watching the little hourglass just tick by. This is usually where we will flip over to the design software and continue to design or set up other cases while it's kind of processing the information. All right, and so this is once it's finished and ready to be sent to the mill. This part is key. I use it a lot. Under the simulation tab, there will be a tab that allows you to see what residual material may have been left by the mill. Now, in my experience, we always see a little bit of that. You can kind of see it in the one edge there where it's green. Basically, that's telling you in the color scale is on the right, how much material the mill was not able to access. Now, I've had this mill for almost 3 years. I will tell you right now that in my experience and in putting a case like this that you see in there, there's been minimal reduction in the mount. Even though the mill can't get to those specific areas, it's been very rare that I've had to go in with pressure indicating paste to have to go in and adjust those areas. But in certain cases where there's a lot of undercut, it's just good to know, or if you're allowed to let your dentist know, where potential sore spots may be or where adjustment areas may be. And this is a cool tool about this software that just gives you a little bit of foresight as to where certain issues may be. But like I said, up until now, knock on wood, I've not had to touch any of the dentures on the inside, on the intaglio side. All right, so that's closing up mill box. So that's where we nest everything. Now what we do is we'll open up vPanel, and in vPanel, there's an area on the top right of your screen with a little drill. Basically what you're doing is you're clicking on that, finding the file and hitting OK, and then the file gets directly sent through to the mill. And that's it. So for us, what we're finding is that upper or lower mill base, we're probably looking at 2 to 2.5 hours. If we're doing a set of teeth on a tooth puck, I would say we're averaging about 45 minutes to an hour. So it's very efficient, faster than I thought it would be. And while the machine is doing this, we're actually putting more cases through mill box to get ready. So in most cases, I'll spend a couple of hours just loading everything up. We'll go over the fact that this mill has 6 different slots for 6 different materials or 6 different pucks, but it allows us to really load everything up and let the mill run all day. What I like to do while it's doing that is set it up so that as I'm leaving, I could like remove the ones that have been finished and then put new pucks in so that as I leave and go home, the mill is going to be milling for, throughout the night, and most of the work will be ready in the morning. The beautiful thing about this mill is the built-in camera, which allows you to see while you're milling, but because it's got remote monitoring and it's got cloud-based software, it allows you to check in on your work when you're not there. And that's key. I used to use it a lot. It was one, I guess, the learning curve, and not so much that you didn't trust, but you just wanted to make sure everything was okay. Now, quite honestly, we've had such little issues with this. I don't check throughout the evening when I'm at home. I just let the machine do its thing, and the mill just, it's a workhorse. So it'll just go through everything that you need it to do overnight while you're not there. But if you choose that you want to, great way of checking in on the production while you're at home or away from the office. The automatic temperature sensor is great because it will adapt and adjust or ask you to calibrate it. Very simple function, but if your room tends to get a little bit hot in the summer or a little cold, it will have you calibrate it to the temperature. With PMMA materials, not such a big thing. With zirconia or other more temperature sensitive materials, this is where you want to key in on something like that. Again, I touched a little bit on this, the remote monitoring in DGSHAPE Cloud. This is the app that allows us to go in and check the progress of work, but it's a really cool tool as well to figure out production levels. So whether you're just doing PMMA or other materials like zirconia, it allows you to check your production, uptime and downtime. A lot of good data here, something we do check regularly. And it's just neat to see the performance of this machine and the amount, especially with errors, just to see how little that is and how much production that you can actually pull from this one mill. So as I touched upon previously, with this machine, you have two types of adapters. You're given one open edge adapter and six what I would call the standard material disc adapters, or your regular adapters. Those are your workhorse when it comes to PMMA. The open edge adapter allows the mill to mill at at a different angulation for more accurate results. So where you would use this would be, I've used this adapter when I've been doing the interior work with the tooth discs. But more so, I think this has a better application with zirconia when you're doing interior restorations. I've played around with it. It does work really well. The mill itself does an incredible job, and I've got some pictures coming up of providing really solid detail and beautiful finish. But this open edge adapter just gives you that little bit more versatility in some of the materials that you may be using to achieve optimal aesthetics. So 6-disc automatic changer, this is big for us. This was one of the things that really drew us to this machine. There are a lot of, as you may be aware, there's a lot of mills out there. Most of them will run one, maybe sometimes two or three. The fact that this has 6 really has changed the way we do dentistry here at our office. Because like I said earlier, we can set this up with 6 discs. It mills all day. And as the discs are finishing up, or as the work is finishing up, we've already got stuff in the queue that we can pull those out, put more discs in, and allow this thing to work throughout the night. So it's been great in that we can leave at 5 o'clock here, sometimes a little earlier, and not have to worry about overtime or, is this case going to be done? The machine just takes care of it itself. And as time has gone on and we've gotten better at using it and setting it, we're finding just a lot less error and a lot less downtime. You have an automatic tool changer. So you have stations for 15 tools. It accommodates both coded and uncoded tools. We have 2 tool sets set up on ours. So basically, this is just another efficiency of the machine. I don't have to go in and change the tooling. We just set it, forget it, leave it, and then just let the software tell us when it's time for the tools to change or to be changed. So here's some of the cases that we've done at our office. The beautiful thing about this machine and what we appreciate the most is when it comes off of the mill, we've just got to trim the spruce and very light pumice, very light, and then high shine or high polish. So the 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 bases coming out of the machine are almost polished. So what you see there in the center, that's directly out of the mill. And then what you see on the right is basically just all we did was just cut the spruce, just soften that area up a little bit, and then took it to the pumice, and then high shined it. So the beautiful thing about the Vigo system that we're using here is that it's using carded teeth. I do think everything has a place and a purpose. We use our technology, be it analog or digital, as a tool. This is just one of our tools in our toolbox. There are times that we need to do milled teeth from a puck. And again, I think we use it to the benefit of what the patient needs in the long term. For our more high-end aesthetic cases, having carded teeth ability to be able to put into a base, the aesthetics, the function, the wearability is just incredible. But the way that this mill will produce is that we've got such high detail that when we do place these teeth in their sockets, it just fits in like a glove. And this is just a case that we did on the mill. This was one that we pushed a little bit, just playing with 3Shape a little bit, seeing how far we could rotate teeth, move teeth. This patient was specific in that he wanted his teeth to look exactly like they did before they came out. The picture on the left is the finished denture, but again, the accuracy, the ability for this mill to produce what it can just allowed us to provide that treatment to the patient that he was very happy with. So when it comes to ROI, what does that look like for us? What we've seen in our lab is that the amount of investing, boil outs, post-processing, deflasking, everything that's involved in making your traditional denture has been like reduced or altogether eliminated. We barely do any of this traditional way, mainly on some of our partial denture work. But the amount of work and time and especially waste has been reduced incredibly. And I think too, what's important to note here is that when we were doing this, we were asked a lot, within our profession and even by friends and family, like, does this reduce your staff? Will this take away jobs? What it's done is it's actually empowered us to hire. Even though we're seeing this type of work being reduced, our workflow, our patient acceptance has been higher. And so we've been able to bring more people on. And going this route for me, what I found surprising was that the training on this was far easier than having someone learn to invest. Having someone set up on 3Shape, having someone set up the mill, having someone remove it, trim it, polish, even place teeth onto the base was much more efficient than having them learn how to process, how to boil out, how to inject, and then how to unpack everything without causing problems. So the biggest thing was that it was minimal finishing, but also the ability to bring on more staff, as well as having easier training when it came to bringing them on board on this. Of course, we've seen less remakes because of fracturing when unpacking. Again, I think it all comes back to proper impression, proper end product. So when we're doing final molds, we're seeing dentures fitting really well. We're seeing zero distortion when we're processing through the mill. Less repairs, less porosities, just generally a better finish overall. And if you look on the picture on the lower left, this one was a case that surprised me. And it was more on the detail of it all. So we took a final mold. It was a light body wash. Patient had incredible detail on the rugae, but what surprised me the most was when we pulled this out of the mill and we almost saw 100% duplicate of the impression in that. We had to soften some of that up for the patient because it was just a little too harsh in the mouth. But it goes to show the detail that this mill is able to produce on a finished denture base. So again, because we're doing less in-house in analog processing, we're seeing less stone, less wax. We're using less energy in the lab. Electricity, especially natural gas, we've seen our expenses go down on that. And we've been able to improve our carbon footprint altogether. So we're seeing a lot less, in the environment of it all, I guess, in the lab is much better. The odors are down, a lot less mask usage, a lot less glove usage, and I would say happier team altogether in the lab. So as you can see here, this is just the reduced downtime on our specific machine. So the biggest things that we've seen on it have been more user area than anything else. I myself or a team member has forgotten to turn on the compressor, so it flags a pressure error. The other one is that we've left, but we haven't cleared out some of the debris in the chamber. When the disc changer drops, it bottoms out on some of that debris, it flags an error. I've only had probably in the three years that we've been using this, I can't even say that we've maybe had 10 tools break on us. But the bigger one that sometimes is out of our control is the overcurrent error. That one's where the burr comes in a little too hard and it binds on the base and it just sends the flag. Not a big deal. Usually what I'll do is I'll pull the disc out with a handpiece in the lab. I'll just open that area up a little bit, run it through its systems again, run the mill again, and it's got no problem. So like I said, we've seen very little downtime when it's come to errors, when it's come to tool breakages. It's just become such a dependable machine and piece of equipment in our lab. Here, sorry, I overstepped myself here again. So just to touch a little bit more on that minimal tool breakage, minimal tool replacement, that's key too. The tools, each of them are listed for 80 hours. And on average, it may take maybe a couple months worth of milling, and we do quite a bit here before you even have to replace it. The correction and calibration, I do it at least once a month. I just do it for my own peace of mind, but really it is run when we've let it go further than that. The machine is very intuitive in when it needs you to do certain things or a little bit of maintenance on it. One of it is the call it maintenance and tightening. It will let you know when it's ready. That technique or that procedure is really quick. Probably within 5 minutes, you've removed it, cleaned it, and put it back in. If you haven't run the machine in a week, it'll just ask you to run the spindle run-in. That's just a quick little bit of maintenance from the machine itself. It takes probably about 25 minutes, and then you're back to running at normal milling. And then, of course, just keeping the chamber clean, the spindles clean, and whatnot. That's probably the most that we do on this machine when it comes to day-to-day maintenance. And that's it. Like, I guess if I could say anything, one of the biggest, the thing that I'm most grateful for is that we were able to partner with such an incredible company. I'm grateful for the opportunity to be here to speak to you on this machine, but DGSHAPE has been a great partner in that they've been always open to asking, like having questions asked of their technology. They've brought me aboard, which has been really cool working with them. But it's just in the quality of it. The fact that we don't have a lot of interaction with our reseller or with DG Shape about this equipment speaks for itself. And it's not because they don't answer whenever you need anything; they're there right away. It's just that this mill has been so dependable for us on the PMMA side of things, that it's mostly how are you doing questions than why is it my mill working. So if you have any questions, please feel free to reach out, and someone will be happy to let you know a little bit more about this technology. Thank you.